Hello students, welcome to online lecture series of discrete mathematics. Now today we will see what is a binary tree. So if this is this binary tree, so you have to consider the first directed tree. Then we will see the simple tree. So for a directed tree, if the degree of each node or every node is less than or equal to 2 in a directed tree, right? Then the tree is called as a binary tree. A tree consisting of a node, that is empty tree, is also a binary tree. So there are basic terminologies are there in binary trees. So first is root. So what is a root? So a binary tree has a unique node called a root of the tree. What is the left child and right child of this node? So what is left child? The node to the left of the root is called as left child. This is A. A is your root node. So left. This is a B. This is a left child of your root node. What is the right child? A node to the right of the root node. Node to the right of the root node. So this C is a right child of the root node. Parent, a node having a left or right child or both is called as parent node. So here A is, you can say A is a parent node of this B and C. Or same here again, suppose D is here. Then this C is a parent node of this B because C having a right child, right? This right child is a D. So C is a parent node of this B. Next, siblings. So two nodes having the same parent is called as sibling. So this node B and C, right? Now this B and C are the siblings of each other because this B and C have a same parent, that is A. Next, leaf, node with no children. It's called as a leaf. So node with no children. So this node B, right? So node B, right? So B containing any children, right? No, there's a no children for this B. So B is your leaf node. Same for this D, right? So D with no children, right? There is a no left child or right child present for this D. So D is also a leaf node. Then descendants. A node is called as descendant of another node if it is a child of the node or child of the some other descendants of that node. All the nodes in the tree are a descendant of the root. Descendants means what? So this A is your root node or parent node. So below this, right? Below this descendants are the C and B. C and B. Same descendants of C is this D. C is a D. Then left subtree. A subtree whose root is a left child of some node. Whose root is a left child of some node. It's called as a left subtree of that node. So see here, suppose this is 1, 2, 3, 4, 5, 6, 7, right? So what is the left subtree? So this is your root node. So left, what? A subtree whose root is left child of some, right? So this 2. 2 is a left child, right? So this is your left subtree and this one is your right subtree. This one is your right subtree. So the examples, a tree shown in figure, right? So which node is a root node here? Before see this complete this example, we complete part here. This right subtree, a subtree whose root is a child, right child of some node is called as a right subtree. So we have seen which one is the right subtree. Level of the node, level of the node is its distance from the root. The level of the tree is defined as a 0. So here whatever level, right, level of the node means what? A level of the node is a distance from the root. So here level of the root is always 0. So here there is 1, 2, and this one is 3. So level of this root node is always 0. Always 0. So level of all other nodes is 1 or more than its parents. The maximum number of nodes at any level n is 2 raised to n. So here root node is 0. So level of this 3 is, level of the node 3 is 1. Right? So depth or height of the tree. The depth or height of the tree is defined as the maximum number of nodes in a branch of a tree. So this is more than the maximum level of the tree. So depth of the root is 1. Maximum number of nodes in binary tree is the depth d is 2 raised to d minus 1. So here remember here height, when you will consider the level of the node, so here level of the root is always 0. While when you consider depth or height of the tree, so here depth of the root is always 1. Start with 1. While the level of the root is start with 0. So when you consider height, height is maximum number of nodes in the branch. Nodes in the branch. So here 1, 2. So height is 2. Your height is, so your level is 1. Level of this 3 is 1. So next, external nodes. The nodes which have no children is called as external nodes, terminal nodes, or we can say leaf nodes. Internal nodes are nodes which have one or more than one children is called as an internal node. That is 1, 2, 3. So this 2 is your internal node, 3 is your leaf node or terminal node, and this 1 is your root node. Then complete binary tree. A complete binary tree is a binary tree if it is all levels except possibly the last, having maximum number of possible nodes for left as possible. The depth of the complete binary tree is having n nodes is log base to the log the base to n plus 1. So this is your complete binary tree. This one is your complete binary tree. Here whatever the nodes, right? So here every levels, right? For every internal node having a two child, right? So this 2 has 2 child, and then 7 has a 2 child, right? So this 4 is having again a 2 child. So every internal node, right, having a or has a 2 children, right? Or you can say every non-leaf node has a 2 children. So here next, full binary tree. A full binary tree is a binary tree in which all leaves are on the same level and every non-leaf node has a two children. So here this is a root node. 2 and 5 are the parent node, and these 4, 3, 6, 7, these are the leaf node. So here all the leaves or all the leaf node at the same level, right? So level for this, right? So 4, this 4, 3, 6, 7 are at the same level, right? And every non-leaf means what is internal node. This 2 and 5 has a two children, right? So 2 is 4 and 3, 5 has two children, 6 and 7. So this is your full binary tree. So we'll see some examples. So here for the your tree. So here which is the root, right? Which is the root here? This A is your root. Which node has the leaves? Which nodes are the leaves? So which nodes are the leaves or terminal nodes? This G, H. We know the leaf. Leaf node means what? Having no children. So G, H, I, L, M, N, and O. These are the leaf node or terminal. Right? So here name the parent node of each node. Parent nodes means what? Having the children. Either one or two. So here A is a parent node of B and C. B is a parent node of D, right? This D and E. C is a parent node of F. K is a parent node of this N and O, right? F is a parent node of this K. J is a parent node of this L and M. So these are the different parent nodes here.